Good morning, everyone. Good afternoon. Good evening, depending on where you are. Welcome to the sensitivity analysis workshop. We're going to start off just with a basic. Let's see why that's not. Basic example of some sensitivity analysis from a paper I did a long time ago, and I just want to kind of talk about initially, the value of sensitivity analysis, why we're doing it, and so this here was a third-party logistics provider problem, A&P model, and we did something a little different than what we're going to do in Super Decisions and Excel today, but the idea is the same here. Ultimately, something that was interesting with this project was I was pretty sure that third-party C, you can actually see it's the one that's always on the bottom. And doing the pairwise comparisons, I was expecting that third-party C would be the preferred choice. And then I came into the final synthesize and it wasn't. And then in the sensitivity analysis, it actually was never the best one. So, again, have you ever been surprised when you've done a model and the answer doesn't come out the way you thought? Another question you might ask is, well, how robust is this decision? Great that it says, if we'd ended right here, great that it says that third-party B was the preferred provider, but as you look at the sensitivity analysis, that's not a very robust decision. It's very uncommon, unlikely through a range of different values that third-party B is always going to be the best one. So again, how dominant is the alternative, the results? And in particular here, we went back and looked, and in these cases, it was when we had fuel costs and warehousing costs rated very low. So that means probably not very realistic. I don't see in the long term these costs significantly going down. Now, you might argue, this is 10 years later with the electric vehicles. Maybe we'd come back and revisit this. But again, it gave me information about when this is happening and what questions to go look at later. And at least at the time, it was like, wow, this third-party A is really robust. This also kind of gives us our first look at, what are important criteria. We're going to look more specifically at a supermatrix to get some more ideas about that. But again, we can figure out when certain criteria change, it matters, and when other criteria change, it doesn't matter. Again, we can kind of look at this as, well, which clusters are more important? This particular graph, I didn't do that type of sensitivity analysis. Again, it built confidence. Now, on the flip side, if this was changing a lot, I could go back in and again figure out where these areas are and say, maybe we want to revisit those comparisons. And again, we'll get into some of these details more as we get into the files. But I wanted to kind of, again, just give us the overall idea. Another important concept is, when we're working with stakeholders or there were multiple people. Now, again, we're not going to look at a group decision today and weighting the group member is different. But again, if we build an A&P model and there's a particular area that's important to the stakeholders, then we can go and we can see if it really matters or doesn't. And I'm going to call this the tomato dilemma when we look at our model here in a few minutes and explain that more. But again, that kind of gives us the overall idea here. And again, I've talked about a bunch of these points about the value of sensitivity analysis, and we'll get into them more. The only other one I want to just touch on now is, again, we can see how much a priority is has to change before the decision changes. And this is important even just for finding limits. So I have here listed a gas price example. So when I teach an analytics course, I have students do a basic model where they're looking at trying to decide which car to buy. And the goal is to be in budget. So you have a certain amount you can spend for the car that's going to affect your loan payment, and gas, how much you're going to drive. And it's set up so they can make trade-offs and say, I really want this bigger kind of muscle car. Well, I could drive less. And so we're looking at some of those decisions. And in one of the scenarios that I give them, it's already under budget. And I ask them, well, what's the gas price that hits our budget limit? And the students will say, well, why does that matter? I'm already in budget. Well, again, if we can find a limit, let's say, again, with the example of gas price, I don't know what gas prices are for you guys right now, but here they're barely under $2 for a gallon. So again, my muscle car, I can drive it. And let's say that I started with that scenario. Now, I've been around long enough to see gas prices a lot higher, and I've been in other countries where it's higher. So again, I need to look at, great that it works right now, but if we have a refinery problem and the gas price goes up $1, I won't be able to drive anymore if I have to stay under budget. So I want to find that limit. And basically, I want to be able to say, okay, is this limit something that's really close? Is it in the range that's most likely? How extreme is it? And again, we'll kind of look at that with a watermelon comparison. So this is kind of the background why we'd want to do sensitivity analysis. I'm just going to briefly talk about some literature. This first one is a paper with Enrique Mew, and we looked at a bunch of A&P studies, and most of them did not do sensitivity analysis. So the main takeaway is we need to do more of this. Gabriel Sava with Luis Vargas and Dr. Jerry May, and Dr. Dolan have done some really interesting A&P sensitivity analysis where they actually get a graph and get regions. So again, it really goes with this idea of where are the boundaries and helps you see, instead of just a line, in this two-dimensional space, this sensitivity area. So great thing to look at. Then I've just got one example. As you see below, there's sensitivity analysis in multi-criteria decision-making, in linear programming and optimization. And if you just search A&P sensitivity analysis, like in Google Scholar, there are many, many, many different ways to do it. And the other thing I just want to highlight is that Bill Adams did an interesting paper in a prior symposium, and basically says with A&P, a lot of the sensitivity we first think about doing isn't going to work. So we've got to be really careful. And it gives some examples and shows, what the potential issues are. So it's definitely a paper you should reference if you're going to do a lot of A&P sensitivity analysis. Now, why, again, do it? There's kind of some competing arguments. Some would say that you do your A&P model, your AHP model, and your answer is your answer. It's kind of like with hypothesis testing and post hoc analysis. There's very strong opinions about how we approach that. Dr. Fauci, who is with the United States CDC, so disease control, was in an interview when talking about COVID, and he said, if you torture the data enough, it's ultimately going to tell you what you want it to tell you. So we can approach sensitivity analysis that way. When I first was exposed to the AHP, the teacher that taught me this in the MBA program talked about it almost as it's the process you go through when you build an AHP or A&P model. It's what you learn as you build the model, and you think about how you have to frame it, and this criteria, what influences this, and those questions. So again, it's the process is as important and sometimes more important than the final answer. And then I'm kind of in this last camp that absolutely the final answer is important. The process, I totally agree. That ability to make pairwise comparisons, and these, as you have to think about the trade-offs, I always learn things when I do an AHP or A&P model. I also think sensitivity analysis is important. And just to get a simple example here, this was back in an optimization class. We had to build a real life model. So we did one in a group about a baking model. And we went to a store and got prices for things. And we decided to get different options for bags of sugar so that, we didn't have to buy this full, really, really big bag, but we could get a smaller one and potentially optimize a little more. And the weird thing was our model chose the smaller bags of sugar. And I'm like, oh no, thinking, what is wrong with my model? Well, it turns out this was strategic pricing on the part of the store. It was basically a cent cheaper. So when you looked at the little price tag and it had the price per serving ounce, whatever it was, they looked identical. But they were strategic, thinking just like people like me that, hey, I'm going to get the bigger one. Well, the bigger one was actually more. So again, I learned something from doing this sensitivity analysis and exploring more. I learned when I go buy sugar, instead of buying the bigger bags in bulk, I've got a big family, I'm going to buy the smaller bags when I shop at that store. So again, I'm in the last camp where I recognize that we can torture data. I recognize the value of the process, and I think sensitivity analysis is important. It's crucial that we understand how the supermatrix works. Again, it's one of the beauties of the AMP is that we don't need to know scales. Or maybe there is a scale, but it's too expensive or cost prohibitive. So we can make relative comparisons, but it's crucial that we pay attention to the unit of measurement. Again, just got some different examples here. Imagine if we were doing a regression and we're using price to predict the sales of something like tamales. If our model came back and told us that we make it more expensive and we'll sell more, we've got to go back and say, does that really make sense? Now, if this is a luxury good, it absolutely makes sense. But if it's something like tamales that I can get at any restaurant, it doesn't necessarily make sense. Another example is I saw an article about Labrador dogs. And the study basically showed that the different breeds have different life expectancies. And that a chocolate lab, which is kind of brown, doesn't live as long as a yellow lab. So again, if I'm not careful and I just say, hey, if I bleach my dog's hair, maybe that's why as humans, we spend so much money, a lot of people on, bleaching hair is, it'll increase our life expectancy. I don't think that's what the model said. I think it's measuring something deeper, in the DNA or something like that. And this is a proxy. So again, don't go bleach your dog's hair thinking they're going to last longer. That's not the takeaway today. And a final example is with pivot tables. When I teach this to my students, I emphasize to them it's hard to get errors. With most of the sensitivity analysis we're going to do, we can get numbers. We're going to get a nice looking graph. But did it really do what we wanted it to do? And I've actually built some questions to help them recognize this. And one of them, I ask them about a particular data set and the number of returns. Now, this is a column that most things don't have returns, so there's blank cells. And if you know things about pivot tables, if there's not a number, it defaults to something else. So when they answer this question in a quiz, they run their data, and it comes back and says that the number of returns in that quarter was the number of items sold. And about 60% of my students put that in as the answer. They don't do the due diligence of saying, hey, if I add up all of these, it adds up to all of my sales receipts for the whole, the number of invoices and receipts for the whole period. This doesn't make sense. So it's crucial that we understand the supermatrix and how it works, that we understand what our sensitivity analysis is doing. Otherwise, we're going to bleach our dog's hair. We're going to go tell our boss, look, you need to charge more for the tamales, or you're going to get pivot tables, and you're going to call an emergency meeting with your boss and say, we've had an astronomical number of returns this quarter because we didn't take the time to know how the data works. And one concern I have today is you haven't seen the background work I've done on these models. So there may be what I call an illusion of knowing as we work on these examples today, like, wow, Orrin just goes through and just does these. Well, it's because I spent the time already to understand the model. So again, recognize that and don't take that for granted today and think you should be able to do sensitivity analysis as fast as we're going to do today. Again, it's because before this meeting, I've done the background to understand the model. So again, we're going to start with a fruit basket example to understand the supermatrix. We're going to do some sensitivity analysis with that in Excel and then also in super decisions. So a little background on the fruit basket model. I'm going to take our data from this example by Dr. Sadi, Professor Sadi, where he showed us how to link from homogeneous clusters to non-homogeneous by using a pivot item. So we're going to go with the values that he gave us. We're really going to assume that the cherry tomatoes that we're going to look at, that their relative contribution is 0.7 and that the watermelon's this size. And that way we're not, going to have to argue or decide about the weights. So what I did is I came up with some fruit baskets. So our alternative one is a variety bowl. So it's got some cherry tomatoes in it, some limes, some grapefruit, a honeydew, and a big watermelon. Then I've got a go green bowl. So we've got small green tomatoes, lime, and honeydew. And then a warm bowl that's got some cherry tomatoes, some limes, some grapefruit, honeydew, and a smaller watermelon, sugar baby melon. Now I just chose these because they kind of made sense for some alternatives in the type of name. And I've gone and put this into Excel and into super decisions. And our goal here is to find out which one of these bowls gives us the most volume, the most fruit, the biggest amount of fruit. So again, in the end, it's kind of a boring decision, something especially with the data that we've got here, that we didn't need to build an AMP model, you could say. But again, it's going to help us, because it's simple like this, to understand how everything in the supermatrix and sensitivity analysis works. So again, we're going to look at these different parts. Let's go ahead and jump into the Excel. So I recommend at this point that you guys follow along in the Excel file. And hopefully you saw the email from Elena. I went through this last night, and as I was teaching it, I was like, oh, maybe I should put a couple other things like comment boxes, and I noticed one error with some of the labels. So Elena sent an email this morning. If you've not updated and downloaded the updated file, I recommend you do that now. So I am in the updated AMP sensitivity analysis. Again, this first slide with the Sadi fruit pivot data, this is just the data that we saw there. And then we've converted them to some different scales here. So ultimately, what we're going to use here are numbers where I'm going to come back and represent each of these items in terms of cherry tomatoes. And then here I just put a sample PCM. If you're using Excel, here's one way to get an approximation for a priority. Now, it is not the eigenvector method, but if you're totally consistent, then this is a way to do it. So just a little background there. Let's go ahead now and start digesting the supermatrix and see how everything works. So again, right here, I've just started out with the data for the alternatives. This again tells me that there were 20 cherry tomatoes, 5 limes, 2 grapefruit, a honeydew, and an oblong watermelon in the variety bowl. And then here's where I converted these into all of the same units. These are essentially saying that the oblong watermelon is equal to 487.714 cherry tomatoes. And this way I can go in and make my comparisons. So I came down here and I just pasted this table another way so that I could make the Excel references easier. The first thing I'm going to point out is in practice, I generally start my decision model in super decisions. And so where I would normally start is over here with the unweighted supermatrix. But in this case, I wanted to build it and make sure we understand how it gets here. So I've come and I've put formulas in. But normally I would go ahead and just export my unweighted supermatrix and get that here so that I can do the comparisons and take advantage of the graphics and visual features that Super Decisions offers. So again, these other numbers here are just to help make those comparisons with hard-coded data. But again, I'd emphasize that I would start with the unweighted supermatrix. So as we come over here, again, I've just taken the amount of value that the cherry tomatoes, sorry, I've got a question here about the basis of conversion into a cherry tomato. So ultimately, to compare these, I needed to have something to relate. So if I come back here, I could compare the cluster comparisons of the small fruit with cherry tomatoes to a small green tomato to a lime. But then how do I relate the lime and the grapefruit or the honeydew or the oblong watermelon to the small cherry tomato? So what I did is I essentially converted everything into the same unit. If this was another decision, it'd be like I made everything into dollars so that I could make the comparisons as we come here. How does the 20 cherry tomatoes relate to the 5 limes? Now I could have used regular pairwise comparisons, but again here I want to be perfectly precise. This is tangible, what you could call tangible data, so that we know exactly where it came from. And again, I just wanted to use Dr. Sadi's data so that we're not arguing, well, I think a lime's really like a 0.68. It's not 9.2 times the size of a lime or a cherry tomato, it's 10, or those type of things. So I'm just going with that data and essentially doing the same thing as if I'd done all the pairwise comparisons. Does that answer your question, Arup? So that was my basis for using the cherry tomato, is again just to follow Dr. Sadi's example and essentially say that I'd made all the pairwise comparisons. So I've got, this column, this cluster right here sums to 1, this cluster sums to 1, this cluster sums to 1. So I need to come back and weight the clusters. Now I've done 2 things here. So initially, I went and figured out what's the relationship between each of the clusters. So Arup's asking using pricing. I didn't use pricing, I used size. There's a reference here to one of the places that Sadi did it. So I guess at this point, go with me that these are the units that I've used. And if you're wondering why it's that particular unit, go look at his example. But go with me right now that it's the size unit that Sadi's defined this. This has been well cited, used in multiple papers, multiple of his books. And so the values that I'm going to start with, again, just assume with me right now, they're solid. So coming back here, what I could do and what Super Decisions is going to do is we would then compare the clusters, and we compare the small fruit to the small fruit, the medium fruit to the medium fruit. and we get cluster weights. You can see here, I just said, okay, take everything that's in the small fruit cluster and compare it to everything else. So I essentially went from doing these type of comparisons to just give me the eigenvector, the priority vector. And we're gonna use the same weights for all of the clusters. But in this example, especially because it's tangible, the relationship between the cluster right here to this cluster is going to be different for this alternative than for this alternative. And so I went ahead and did those comparisons for each column. And then I've come over here and used those weights, and I've created a weighted supermatrix. So essentially, again, we're going to start with our unweighted supermatrix, where we've just done our pairwise comparisons. We'd export this from super decisions. Notice I hard-coded these as zeros because there's nothing in there, and I didn't want to divide by zero error. So that's why those are highlighted. But I would paste this data from the super decisions. The question is, how does this one, notice down here that it sums to 1, relate to this one? How do the clusters, I need to aggregate them so that I can be column stochastic. So again, I would do cluster comparisons, and that's what we've done here. In the next step is I take these original values and I weight them based on the cluster comparisons, which now gives me an idea of how did this number here relate to this number here. And we can see that you might look at this and say, well, they're almost the same. Well, in terms of the actual size or value they add, they're different. So again, our weighted supermatrix comes in, it converts all of these ones to their relationship to the other clusters in the column. And we have to have a column stochastic supermatrix to raise to powers, or we run into all sorts of other issues. So again, it's important that we understand how are we getting from the unweighted to the weighted. We're going to come back and weight all of these clusters. Now, in our case, since we're going to be changing some of these values, we need to essentially get a new weighted supermatrix, and we're going to have to renormalize. Because ultimately, what we're doing with the sensitivity analysis is we're coming in and saying, you know, I don't think that was 0.69. Or now in terms of the whole network, I don't think that was 0.68. What if it was more? What if it was less? And then we have to capture that change and show the difference and how that would change our decision. So simply put, we're just doing, if you've had an analytics course, basic what if analysis per se. We're going to go back in, and instead of coming here and hard coding that and saying, well, change that to 0.08 or change that to 0.20, and then of course we'd have to renormalize now because it adds up to more than 100%. We're going to do this in a way that we can see a whole range at one time, okay? So let's come down here. Again, we saw that when I put other numbers in, this changed to bigger than 1. So I have to reallocate the values. And this is a big question. How do we renormalize? Well, it depends on your model and your sensitivity analysis, what the question is you're asking. And we'll talk about that a little more as we go on. So we get a renormalized weighted supermatrix. And again, I have my original data here just so that I could compare it. And then I'm going to come over. I'm going to take that renormalized supermatrix and just put it right here. And then we've got to raise it to powers. So I'm not going to focus today on how do you build a model in Excel, because that's a whole lesson in itself. We've got our weights. We've got our example, and over here I did the same thing with my original one. So let's jump in now and actually do some sensitivity analysis. So I'm going to start with this basic sensitivity. And I'm going to look at my weighted supermatrix. Sorry, I need to tell you one more thing I forgot. Part of this understanding our model, I've got my final priorities. These are from the limit matrix. So we can see right now the variety bowl is the one that's got the most amount, then the warm bowl, and then the go green bowl. And here's how my criteria contribute to the system. So I told you before about stakeholders. Think of me per se as a stakeholder here, and that I love tomatoes. Now my garden froze about 3 weeks ago. And so if it was my choice, I wouldn't eat a tomato again until about next June. So to me, tomatoes are really important. We get valuable information from the weighted supermatrix and the limit matrix. We can see right here that the tomatoes don't contribute very much. So no matter how important I think they are, I'm in the meeting and I'm arguing with you. Well, no, we've got to fix the comparison between the cherry tomato and the lime. The lime wasn't that important. From the limit matrix and from sensitivity analysis, you can do that analysis and come back and tell me, I know you think that's important. Let me show you. Let's give it more and more weight. It doesn't change the decision. It doesn't matter here. So again, it's really important that we take the time to study our weighted supermatrix and our limit supermatrix. Here, we can see that the watermelon and the honeydew are some of the biggest contributors. These are the ones where if things change, it could change the decision. And we can see that because they're the biggest contributors. So in this first one, I'm going to look at the honeydew. Wow, time's flying. Glad I sent the updated file. So what I want to do here is I don't think I got the contribution of the go green bowl quite right. When I compared the honeydew in the variety bowl and the warm bowl to the go green bowl, I'm not sure if I got it quite right. So I want to change this value, and then with respect to these other comparisons. So what I'm going to have Excel do is I'm going to have it plug different numbers in here, like to literally come back and say, what if that was 0.1? What if that was 0.2? What if that was 0.9? And as it does that, notice now my column doesn't add up to 1 anymore. I have to renormalize. So I've come in here and I've said, okay, take the difference from 1 of this value, and then based on the relationship of these two, take that remainder and assign it to them. So we can see in the original example, these two were actually the same. And if we go back and look at the data, again, if we understand, it's because they each had 1 honeydew. They had the same amount. So in this case, they're contributing the same amount to that overall cluster. So I'm going to come back and say, well, if that was really a 90, then split the difference equally between these two. Follow the same pattern. So that's the formula there. So I'm just going to undo and undo. So this gets back to the original number. I didn't need to do that. And then I come down to my what if table. Again, I don't want to focus right now on teaching you what if tables. If you have questions about data tables and what if tables, there are tons of YouTube videos. But essentially what I did here is when I was plugging numbers in manually up there, I did that all at once. And so we bring up a box. We're going to go to data. Whatif analysis, data table, and it's going to ask us to either put something in the row, in the column, or both. In this case, we're going to take stuff from the row, because these are the numbers, and we need to tell it where to plug it in. And I'm going to tell it to plug it in W19. So again, this is just going to regenerate the same table. So I'm going to come over here, and I'm going to say, plug those different values in right there for me. And I click OK. Oops, sorry, I was in the wrong spot. I should have told it to plug it in right there. That's why it's W19. And it's going to give me this table. And then I simply graph it. So let's go over to super decisions and see what we just did. So I've got my network open here. So again, I just built the same model actually in super decisions. I'm going to go to computations, and I'm going to do the AHP sensitivity. Now, later today, there's a tutorial. Bill Adams is going to talk about AMP row sensitivity. And again, he addresses some of those concerns that he talks about in that paper about the sensitivity. Great session, recommend you attend it. So I'm going to bring up this graph, and the first thing I want to do is go to edit and change the dimensions. And I'm just going to put in 1200 right now for all of these. So that it makes that graph bigger. So all I did, I picked 1200 because I tried some numbers before the session, and that gave me a pretty good sized box. You could have done 800, you could have done 2000. Then we're going to come back to edit. We want to edit our independent variable. Now there's a bunch of options, but we're going to focus on two types today. So I need to click here, and I want to edit that. And in this type of AMP decision where I've only got one network, I'm going to use the Supermatrix. So again, here my parameter type is Supermatrix. And now it asked me a with respect node. That's essentially asking us, if we come back over here to our weighted Supermatrix, which one of these columns do you want to be in? Well, I want to be in the Honeydew column. So I'm going to change the node to Honeydew. And now, what's the other node it's going to change? Where is super decisions going to come in and plug numbers? If we come back over here, I plugged it into the Go Green Bowl. Get all those screens back up. So I chose the Go Green Bowl. And the one other thing I'm going to change is I'm going to put more steps in. Now we can definitely start with 7. That's essentially going to do 7 different calculations. But I want it to be a little more precise, so I'm just going to do 20. Now, are there reasons to do 50 or 5 or 20 or 25? Absolutely. We're going to hit done. And then I'm going to update. And now we get this graph. And we can see that as the value of the Honeydew changes, the alternatives change. In fact, is that Honeydew that was in the Go Green Bowl, if it gets more and more important, think of it again now, it's almost like saying that the honeydews in that alternative get more and more bigger. Well, eventually, the Go Green Bowl becomes the best. And we might be interested in these points right here, where they change. This is kind of like the cutoffs that I was talking about the gas price. So again, think of it in terms of gas prices. At a certain point, if gas were, $12 a liter, is that really, I mean, it changes, but is that really going to happen? Now, if it's more like this was saying gas was at $1.25 a liter, well, yeah, maybe we need to go back and look and see how precise that was. And we might be interested here where it changes. So again, this gives us some information. I've only got a few minutes left, so let's go ahead and look at how to do it in a more complex model. I was hoping to do 2 examples in each, but time's running out here. So let me close this part and get the other model, which was the relocation of corporate headquarters. And briefly tell you a few things about this. So what I've done here is I've just taken part of that decision, and I took the benefits network and did the subnetworks and how we got from the subnetworks to the overall priorities for the benefit network. And then I show those all for the benefits, opportunities, costs, and risks. And then over here, it's how we got from those. We did our strategic criteria comparisons. We did our ratings model, which gave us these numbers. And then I renormalized them. So I get my priorities for the benefits, opportunities, costs, and risks. And then I built my final model to get my final ratings here. Now there's an issue that for some reason super decisions didn't use the ideal for the benefits. So I actually built this other one. I can show you from the report. Right here it uses 9692 instead of ideal. And I have the numbers over here in the output. So this box here will tie out exactly to super decisions. So this shows us what's going on. Let me flip back over and just mention a few things, and then we'll do these 2 forms of sensitivity analysis. So again, here I had my strategic criteria. I have my benefits networks. And you can see inside my benefit network, if I go in there, I had an economic, a political, and social subnetwork. So that is these subnetworks here. And then again, at the top, I had all the subnetworks combined. And we're going to look really quick about the sensitivity analysis at this level, and particularly at this level. And then I'll show you why we have to be careful with AMP sensitivity analysis. So let's come back here to computations again. I'm going to go to, again, the AHP sensitivity. Again, I'm going to edit and change my dimensions to 1200, 1200, 1200, 1200. I'm going to go to edit. I want to change my independent variable. So I'm going to edit again. Now this time we're going to use a different one. It's the priorities. So if we see here, the comparisons here, the weights for those are from the priorities from the ratings model right here. And so we can't use the supermatrix because the software doesn't use the supermatrix in that form. So I'm going to use priorities, and I'm going to start with the benefits. So essentially what I'm saying here is change the value of the benefits. Okay? And I'll just update. And what this has done, we're going to jump back over to Excel, and let me show you there what it's done. Look at the graph. Again, we can drag this along. And we can see that there's a certain point where the alternative that was best now becomes best. And again, we can see things like, you know what, no matter what, if we look down here, this is the status quo. Staying put is never the best thing as we change the weight of the benefits. So again, we get information. It's kind of like the tomatoes again. Guys, those of you that are scared of change, we're never going to reap the benefits, no matter how you weight them, if we stay put. Kind of makes intuitive sense here if this model is about relocation options. So what did that do? If we come to this second one, essentially what we said is change the weight of the benefits. You know, make it really small, almost zero, and make it bigger and bigger and bigger until it's a 1 and it's everything. And then come back. And again, I wish we had time. I could explain to you exactly what super decisions is doing. Elena will be talking about this in even more detail today in her presentation when she talks about how the BOCR works. And we have to renormalize. So I essentially said, take 1 minus whatever the new benefit value is. So if the benefits, we're going to say, give it a value of 0.1, then take that other 90% and give it to the opportunities, costs, and risks based on the same relationship they shared there. And then I came down here, and you can see our graph basically looks the same. And I plugged in a lot of different values for the benefits. I said, make it basically 0, make it 0.5, make it 10, make it 15, and I graphed those. If we come over here, we did the same thing for costs. So you can, or sorry, for opportunities. So you can come back in and see how the formulas would change if you want to change opportunities. How do we do that here? We're going to come back. We're going to edit again. And it's as simple as coming here to opportunities, done, update. And again, this one looks pretty similar to the other one. And there's reasons why if you go look at the different super matrices and the priorities, the opportunities and benefits were very similar in the way the values that they contributed. So that's why it's the same. So let's look at one more. Again, let's look at the risks this time. Wow, that changed a lot. So we can see now as the risks get weighted more and more and more, somewhere about over here at the 0.7 value, all of a sudden, doing nothing, the status quo, is the best thing to do. Well, it makes intuitive sense. It's the least risky. Last thing I want to say is in this other one, I came into the benefits subnetwork and I changed the value of the different clusters. You know, what if the social is really more important than we thought? And this explanation, read it. Again, this could be interesting to do for the stakeholder argument, but a challenge here is as the social changes, the ideal in the social was different than the ideal in the benefits. And because we use the ideal as we aggregate, as we change the values here, we almost have to go and redo the ratings model. We'd have to come back here and change the values that came from the ratings model. And that's why we can't easily, in super decisions, do more sensitivity analysis at the lower levels, is because it changes the way it feeds in. So this explains that part. Now, man, time flew. Just as we wrap up, again, It's crucial that we understand the supermatrix. There's issues about how we renormalize, and some of the other examples that were in there for the fruit model go into that. It's important to make good quality graphs, so I recommend you eventually export something to Excel. These concerns that I started to talk about at the end about how to reapportion weights, there's been no consensus in the literature. There's different ways. And the most important thing is that you can validate your argument. So as you understand the supermatrix, you say, this is how I'm going to reapportion, and this is why. Just be transparent and defend that. Again, there's issues with doing it in super decisions and some limitations. And so I generally do it in Excel, and that also helps me have control. So I appreciate your time, and I hope that gives you a better idea. And again, feel free to use this Excel model as a template and to go back in and look at the other sheets. And again, you can go back and watch the video later. So if you had questions, how did you do the data table? Why were those formulas what they were? You can go back and do that in detail. But this really gets you going to where you can do sensitivity analysis in any of your models going forward. Thank you. Have a great day, and hopefully you enjoy some of the other tutorials.